Hi, I'm Lee Teschler with EE World and Design World. I'm here with Rakesh from Infineon. And Rakesh is going to tell us a little bit about an interesting demo we have going behind us about 8-phase power for multi-core processors. Rakesh, what's going on here?
So what you see here is a demo of a VR, a voltage regulator solution for high performance computing kind of applications, wherever the power levels are really high, right? So this is our latest Intel VR13 compliant control IC that can support all the way up to 8 phases. This is the only controller in the marketplace that can support all the way up to 8 phases. So there are two things going on. The controller that can enable those phase counts and then efficient power stages, right? So what you see here on the display is a solution that's running at 400 amp, really high current, and it's still running pretty reasonably efficient and with a very reasonable amount of airflow, right? The controller enables the use of so many phases, and the power stages themselves are so efficient that we can support and provide such a solution to the market.
Before this was available, how would you get 8-phase power into it?
There was no 8-phase controller because typically the CPU power levels were lower, and now what we are seeing is the power levels are going up, and this generation it's just been tremendous increase, right? And we're expecting to see that increase even more in the next generation. So 8-phase is a pretty good number for where we are now, but the power levels are definitely increasing beyond that.
And the thermogram you have here of what's going on, what temperature are we actually seeing here?
So what you're seeing is the hottest spot on the board, right? So the power stages themselves, they carry bulk of the current, right? So they're the ones who are typically hottest. You got the inductors here and then the power stages, which is the most efficient power stages in the market, right, from Infineon. So even at 400 amp, which is 50 amp per power stage, is still running a little less than 100 degrees, right? And can consistently run forever. Right?
Interesting. Now you've got another example of 8-phase power over here behind us. Let's move there.
Yeah, sure.
Rakesh, we've got a pretty heavy-duty video gamer running right behind us. Tell us a little bit of what's going on here.
So this is a typical gaming motherboard. If you know what the gamers do is they try to get more performance out of the CPU than what it's designed to, right? It's basically overclocking the CPU. So what we have is, the motherboard is what you see here in the background with the heatsink on the front for the CPU. This is the actual motherboard that's stacked up on the system, right? So what you see here is our Infineon solution. It's an 8-phase power converter that can deliver as much as the current we saw on the previous demo. But this one has a special controller that can enable these gaming features, right? That allow us to overclock, or the gamers to overclock the CPU and get better performance. And what you see here is multiple operations going on, right? You got a HD movie running in the background with a 4K display for a game, and then a movie conversion process. Everything running together, and the CPU still functions fine, right? And you can see on the display here, you're already 20 to 30% more power on the CPU. So it's totally enabled by the digital controller technology that we have, right? And the power stages obviously can deliver the power that you need.
What's the actually the difference in clock speed that you're doing here?
So the CPU is designed for a 3.3 gigahertz max, and what's running right now, it's about 4.26 gigahertz. It's almost like 30%.
30%, sure.
Which is pretty substantial. And you can see it, I mean, it's stalled right now, but you have an HD movie here, and then the game, right?
Yeah.
It sucks a lot of power, right? And you need something like this for that.
That's pretty cool, Rakesh. Thank you.
All right, thanks, pleasure.